Hello students, this is a video about motion problems. You have several types of motion problems in your notes from yesterday, and I'm going to go over a couple of different problems. There's just so many variations of these motion problems, and the more you see, hopefully the better you will get at figuring out how to set each type of problem up. Okay, let's look at our first example. John and Philip, who live 14 miles apart, start at noon to walk toward each other at rates of 3 miles per hour and 4 miles per hour, respectively. What does that mean, respectively? Well, what that means is in that same order. So, since John comes first, he's walking at a rate of 3 miles per hour, and Philip comes second, he's walking at a rate of 4 miles per hour. In how many hours will they meet? So, the first question to sort of ask here is we're trying to find a time. And are they walking for the same number of hours? Do they both leave at noon? Yes. And at some particular time, they run into each other. So yes, they are walking for the same amount of time. So we're going to say time, T equals the number of hours until they meet. Okay, so I'm going to start off with a picture. I've got John here. Let's draw John. There we go. And I've got Philip over here. Here's Philip. And they live 14 miles apart. So let's just make that kind of clear. Actually, let me just back up here. Let's make that clear up here, that they live 14 miles apart. So every bit of information that I get in the problem is important to put into my diagram. Okay, so I've got my 14 miles. John starts walking, okay, and he walks a certain distance. Philip starts walking at the same time, and boom, they run into each other, and they meet, and that's the red dot. So the question is, if one of them is walking slower and one of them is walking faster, are they going to meet right in the middle at 7 miles, right? Each of them walking 7 miles, or is one going to walk a little further than the other? So hopefully you figured out if one is walking faster than the other, that one person, Philip, is walking faster. He's going to go further, right? We don't know how much further. That's the part we need to figure out. But the question, of course, is how many hours are they walking until they meet? So we're going to get help from our equation, our DIRT equation. D equals distance equals rate times time. That equation helps us out a lot with this problem. So we don't know the distance that John walks, but what we do know is his rate, 3 miles per hour. And we don't know Philip's distance that he walks, but what we do know is his rate. And since D, the distance, is the rate times the time, we can call this distance that John walks 3t. This distance is 3t. 3 miles per hour times t hours is the distance that he walks. Philip walks 4t. That's 4 miles per hour times t hours will give me a distance of 4t miles. So now I can see that John walks. Okay, where were we? So now we're just going to add together the distance that John walked to the distance that Philip walked and set it equal to the 14 miles that they started off apart from each other. So let's see. Let's do green. The distance that John walked is 3t. The distance that Philip walked is 4t. And the total combined distance is the distance that they live apart from each other, which is 14 miles. So I end up with 7t equals 14. Solving for t, I get t equals 2. I look back at my key. T is the number of hours until they meet, so t is 2 hours. And when I look back at my question and read the last line, in how many hours will they meet, I know that this is my answer. If it had asked at what time do they meet, I would have added that 2 hours to noon, and I would have gotten 2 p.m. So it's important to go back and read your question at the end. But that's it for that problem. Okay, here's our second problem. A 550-mile, 5-hour plane trip was flown at 2 different speeds. For the first part of the trip, the average speed was 105 miles per hour. Then the tailwind picked up, and the remainder of the trip was flown at an average speed of 115 miles per hour. For how long did the plane fly at each speed? Okay, so it flew a total of 5 hours. And for a certain number of hours, it flew at 105 miles per hour. And for another number of hours, it flew at 115 miles per hour. Let's start off with a picture. So I'm just going to draw an arrow to illustrate the entire plane trip. Okay? And we know that this distance of this plane trip is 555 miles. So I'm going to go ahead and put that into my drawing. And then it was flown at 2 different speeds. So part of the trip was flown at 105 miles per hour, and part of the trip was flown at 115 miles per hour. Now, this is hard to put into a picture, but the whole trip, the entire trip was 5 hours. Okay, so the whole trip equals 5 hours. Okay, so we also have the slow part of the trip and the fast part of the trip. The slow part of the trip, we don't know how many hours that was. So we're going to call it X. Or actually, let me back up. Let's call it T, because I like time to always be T, and that helps us recognize what we're talking about. If the slow part was T and the whole trip was 5 hours, we can subtract the slow part from the whole trip to get the fast part. So be careful now. It's the whole trip, which is 5, and we're subtracting the slow part, and that gives us the fast part. So be really careful what you're doing here. In this case, make sure that you're taking the whole thing and subtracting part to get the other part. So now we know the time for the slow part and the time for the fast part. And going back to our equation that helps us out every time, distance can be replaced by the rate times the time. So I don't know this distance, I don't know this slow part distance, but I know the rate, which was 105, and I know the time, which is 5 minus t. Oops, that was the fast part. Let me go back. I know the time, which is for the slow part, which is t. And the fast part, I don't know that distance, but I do know the rate, which is 115, and I know the time, which is 5 minus t. And by the way, doesn't matter in terms of the t and the 5 minus t, doesn't matter which is slow and fast. So we have an equation here, and now I know that this, sorry about that, this first slow part distance is 105 t, and the second fast part distance is 115 times 5 minus t. So now we can say we have it broken up into 2 different distances, and when we add the slow part distance to the fast part distance, we get our total distance of 555. So let's look at that equation. We get 105t plus, so we're adding them together, 115 times 5 minus t, and that is equal to 555 miles. Again, distance, slow part distance, plus fast part distance equals the total distance. Okay, and then simplifying further, I get 105t plus 575 minus 115t equals 555. Okay, and further solving here, we combined the t's to get a negative 10t plus 575 equals 555. Subtracting 575 from both sides gives us negative 10t equals negative 20. And solving further, we get t equals 2 hours. Now, going back to our original problem, we get t equals 5 hours and 5 Oops, that's what I get for going back. T equals 2 hours. 2 hours. Okay. And 5 minus t, 5 minus 2 equals 3 hours. And so going back to our key here is helpful for solving this. The slow part of the plane trip is 2 hours. The fast part of the plane trip at 115 miles per hour is 3 hours. So hopefully this is helpful in terms of helping you draw diagrams and think through some of these challenging problems. And you might want to come back to a couple of these if you get something similar on a homework assignment. All right, have fun.